Okay, wonderful people. We are going to be dividing decimals now. And if you're tracking your notes, again, this video is spring 2020 during the coronavirus saga, at home instruction for my students. So if the public benefits from this, good for you. But if this seems unorthodox or raw, it wasn't meant for you. It was meant for my students who understand me. All right, good. So when dividing a decimal, we said that your divisor cannot be a decimal. I repeat, your divisor cannot be a decimal. You must move the decimal point. Like when we were moving to do our multiplication of your divisor, but with division, it's different, right? You move the decimal point of the divisor until it becomes a whole number. So here, I'm going to move my decimal point 2 places, 2 dp, right? As we early established that dp is decimal place. Okay. And then as in the case of multiplication, we usually make both factors whole numbers. But in the case of division, you make the divisor a whole number and you move the dividend. So let me identify. This is called the dividend. That's the number you're going to divide. And the number that's dividing the dividend is called the divisor. All right. So we're going to move the dividend according to how many times we move the divisor. So because we move the divisor 2 decimal places, we only move the dividend 2 decimal places. So the moral of the story here is that your dividend can still be a decimal number, but your divisor cannot. Okay, so your new expression should look like this: 4,175.6 divided by 576. Another caveat too is that, remember when we were doing multiplication, we would move the decimal point of our product back according to the total times we move the decimal places for each factor. Not in this case. We can leave it as is and it will be the correct answer. So here I'm going to do my division. I'm going to set it up as a long division. And this is really, really big factors. I really hope they don't do this to you on the exam. So now we have to find out how many factors of 576 we can find in 4, 41, 417, and 4,175. So it's obviously that we'll have to find factors of 576 and 4,175. And I'm going to look like a genius. That is actually 7. And I only look like a genius because it's in your text. Okay, good. For demonstration purposes, I'm going to be explaining it. So you can find 7 factors of 576 in 4,175. And when I multiply the product of my divisor and partial quotient, I call this a partial quotient because it's not fully the quotient as yet. It's my own terminology. If I multiply these product, it's actually 4,004. And we know that our next step is to subtract, right? Which is 171. And then we take up our decimal point, right? And then we're going to bring down our next digit and repeat. Okay. So how many factors of 576 can we find in 1,716? And I think I can make a strong guess this would be 3. And actually, if you times 3 by 576, you get exactly 1,716. So we got really lucky here. The quotient of this enormous expression here with this large divisor and large dividend is 7.3. Here, the decimal, whenever you have no remainder, even though you use decimal, we can say the decimal point terminate. If you remember in your notes, I gave you about 3 to 4 different cases in which your answer could either terminate, reoccur, or go on to infinity. All right. So that is one example of how to divide decimals, where the caveat here, the thing to really, really pay attention. You perform division as you know, long division as you know, but your divisor cannot be a decimal. Okay, so let's try another one. Here we go. Here we have two decimal numbers. Again, my divisor is 0.6, so I'm going to make this into a whole number. I only move it one place, so that means I can only move my dividend one place. Remember, the divisor dictates the movement of the decimal point in the divisor dictates the movement of the decimal point in the dividend. Also remember that your divisor has to be a whole number and your dividend can still be a decimal. So my new expression is 4.7 divided by 6. This looks so much more friendly. All right. Or I should say friendlier if I'm to speak proper English. But if you notice by now, I don't speak proper English. I'm not proud of it, but this is not the forum for me to speak proper English. I hope you can understand the math. That's what counts. All right, good. Moving on. 6. So this is 4.7. So I can't find any factors of 6 in 4. So I'll represent that with a 0. And then I'll bring up my decimal point and bring down the next digit, 47. And I can actually find, if I know my 6 times table, I can actually find, I was going to say 8. 6 8 is 48, so that's not going to count. So it's probably 7. 6 times 7 is 42, so I can find 7 factors of 6 in 47, so that's 42. Subtract and see I have a remainder. Now, if you recall in your notes, I said that if a decimal does not terminate, the standard of the institution is for you to add 4 zeros. 4 zeros, and then you can finish there, because sometimes decimals can go on and on, or they can reoccur. And if you see there's a reoccurring pattern, then you could just stop at the first one or first two. I also said that I'll accept 3, just to save you time. I'll know that you get the point. All right. But for the sake of keeping the integrity of the institution, I added 4 zeros, and then I'm going to continue. So here we go. I'm going to bring down a 0, and I can actually find this time 8 factors of 6 in 50, which gives me 48. Subtract, bring down. I can find 3 factors of 6 in 20. 3 times 6 is 18. Is it? Yes. Did I say 3? Yeah. 18. Subtract, bring down. And it's 20 again. So it's another 3. What am I doing? 18. And it looks like the 3 will be reoccurring from here. So I'll stop here. And I see that my quotient for this decimal, 0.47 divided by 0.6, or properly stated, 47 hundredths divided by 6 tenths. And in case some of you are looking at me crazy, for the public, we did a video based on how to write decimal in words, so I'm reinforcing that concept. Otherwise, I'll just take plain old 0.47 divided by 0.6. That's fine, as long as you know the proper terminology. So the answer here for this is 0.78333. Now, let's say they had asked you to round to the nearest hundredths, right? So if that asks you to round to the nearest hundredths, that is great, because sometimes when they ask you to round to the nearest place value of something, you may not have to work on all 4 values. My advice to you is when they ask you to round, go 1 extra place, right? Go 1 extra place. So when rounding, go 1 extra place value from what they're asking, from what they are asking. All right. And this is what I mean by this. So when rounding, go 1 extra place value from what they are asking. So what I mean by that, if I ask to round to the nearest hundredths, so my hundredths place is the 8, digit 8. So how will I know whether I'm going to either, my place value digits is going to be increased by 1 or stay the same? I have to gauge that by the number next to it or the place value next to it. And if the place value next to it is 5 or more, then I know my 8 will increase to 1. So that'll be 0.79. Or if it's less than 5, as in the case, it will stay the same and all other digits behind that will zero out, or in the case of decimal, terminate, not exist. So in this case, if you were to round to the nearest hundredths, it would be 0.78 to the, just handing this to the hundredths place, right? Let's say I want to ask you to round it to the nearest tenths. So notice I didn't have to add 4 zeros and do all of that. I just go to the thousand space, right? 7 is in the tenths, 8 is in the hundred. So basically, I only would have had to add 2 zeros if I was just asked to round to the nearest hundreds. Let's say I asked to round to the nearest tenths. So here, my 7 is in the tenths place, and as I can see, the place value next to 7 to the right of 7 is greater than 5. That means this will be increased by 1. So if I'm rounding this to the tenths, it would be 0.8. So this is to the tenths. So that's how you will treat division of decimals. If you have any questions, concerns, or confusion, please feel free to private message me so I can take care of any of your issues. All right, we're moving on to the next phase.